homework, so I gave you 24, 25, 24, 26, 27, 28, 29, yeah? Yeah, right, okay. Who needs me to do 24? Yeah, okay. So 24 is... Yeah, I'm record. No, did I did press record. I'm okay. Yeah, I'm good to go. Log to the base 10 of x squared plus 6 minus log to the base 10 of x squared minus 1 equals 1. So you either change it to a log on one side equals a log on the other side, or a log on one side equals a number and you change it back to an index. In this case, I'm probably going to be squashing this into one log, right? And this is a number, so I'm going to change it back to an index. Okay? So the minus means these were originally what? Divided, isn't that right? So take away means they were originally divided. So that was originally x squared plus 6 on top, x squared minus 1 on the bottom. Agreed? Equals 1. Right, so when you have a log equal to a number, you change it back to a power. So the base of the power is 10. This is the power, and this is the answer. X squared plus 6 all over x squared minus 1. Is that okay? Right, so 10 to the power 1 is just 10. So what will I do? What will I do now? How will I fix this? I either get a common denominator or I do, because I have a fraction equal to a fraction, what could I do? Cross multiply. So top by bottom, it doesn't matter which way you go. X squared minus 1 equals 1 times x squared plus 6. Are you all okay with my cross multiplying? Right, multiply out to get 10x squared minus 10 equals x squared plus 6. Everything over to the left, you get 9x squared minus 16 equals 0. That's the difference of two squares, isn't it? Right, so that's 3x to be squared, take away 4x to be squared. So that's a 3x and a 3x, a 4 and a 4, a plus and a minus. Agreed? Right, let each bracket equal 0. So you get 3x minus 4 equals 0. And you get 3x plus 4 equals 0. Rearranging, here I'll get x is equal to 4 over 3. And here I'll get x is equal to minus 4 over 3. Just make sure that they're both valid answers. Okay, so substitute back in. And actually the minus doesn't matter here because they're both squared, aren't they? So they'll both end up being log of a positive number. Won't they? They will. Because when you square there, you'll get 16 over 9, take away 1, which will be 7 over 9 or something. Right, okay, so it'll be fine. They're both valid answers, so done. Is that alright? Okay, are we all good? Any questions? No. Right, okay, 25? 25 you didn't have. 26 was next. Do you want me to do 26? Yes, no, maybe? Yeah. Right. So 26 is log of, they don't give me a base, 2x plus 3 plus log of x minus 7, x minus 2 even, equals 2 times log of x. Right? It doesn't matter that they don't tell me what the base is. Right? Okay. To be honest, most times I would assume if there was no base, it was log to the base 10, because that's what it is in the calculator. Okay? But it doesn't matter anyway, because they're all the same, aren't they? So you can assume they're all the same, and that's all you need to know. Okay? So I'm turning this log on this side back into one log. So if they were added, that means they were originally multiplied, weren't they? So that's 2x plus 3 multiplied by x minus 2. Agreed? Over here, there's a 2 in front, so I needed to bring it back up as a power. So that was originally log x squared. Agreed? So I have one log on one side equal one log on the other side. What can I do? Knock off the logs. Okay? So you either have a log equal to a number and you turn it back into an index, or you have a log equal to a log and you knock off the logs. Okay? Multiplying out here, I'll get 2x squared minus 4x plus 3x minus 6 equals x squared. Okay, so multiplied out. Right, now I'm going to tidy it up. Bring over that x squared. It becomes 2x squared minus x squared is x squared minus, minus x minus 6 equals 0. Factors x and x, 2 and 3, minus 3 plus 2 will give me minus x. Let each bracket equal 0, x is equal to minus 2, x is equal to 3, and then just go back up and check, okay? If x is minus 2, I'm going to end up getting the log of minus 2, right, okay? Which you can't get the log of a negative number, so this is not a valid answer. This is the answer. Is that alright? Sorry. So you just have to give a quick check at the end to make sure both are valid answers, because you can't get the log of a negative number. Okay, are we good? Okay, 20, that was 26, what was next, 27, am I doing it? 27, anyone? Yes, no, maybe? Yeah, okay, so log to the base 10 of 17 minus 3x plus log to the base 10 of x equals 1, right? So I have logs at this side, numbers that side. I'm going to be turning it back into an index, okay? So if they were plus, that means they were originally multiplied, okay? So it's 17 minus 3x multiplied by x, right, equals 1. We good? Okay. Log at one side, number at the other side, right? Log at one side, number at the other means I'm turning it back into an index. So here's the base, here's the power, here's the answer. Equals 17 minus 3x multiplied by x. Is that right? So that would be 10 equals 17x minus 3x squared. So that would be 3x squared minus 17x plus 10 equals 0. Factorize 3x and x, 5 and 2 and a minus and a minus. Okay, let each bracket equal 0, so you get x is equal to 2/3 and x is equal to 5. And they're both valid answers, aren't they? So if you put the 2/3 and the 5 back in, you can get, just make sure the 5 there, you'll be getting 17, take away 3 times 5, which would be the log of 2, which is okay. You can get the log of a valid, so they're both valid answers. Is that okay? We all good? 27, 28, am I doing it? Yes, no, maybe? Nobody's saying yes, so I'll take that as a no. Yeah, is that okay? Right, and then 29, did I give you 29? Yeah, am I doing 29? Yeah. So 29, given that 2 log of x to the base 2 is equal to y, and log of 2x equals y plus 4. Find the value of x. Right, okay, let's go with this. See this one, right? Okay, wait now, let's see. Here, will I split that up? Just give me a sec. Yeah, I'm going to split this up. Log of 2 of 2. This is a product, isn't it? So I can split it up and put a plus between them. Agreed? So I split the 2 and the x. Is that right? Okay. Equals y plus 4. Am I good? So 1 plus log 2 of x. Log of 2 to the base 2 is 1. So 1 plus log of 2 of x equals y plus 4. See this term here, I'm going to replace that with a y, okay? You know, using this one over here, log 2 of x is equal to y over 2. Just dividing across by 2. Agreed? Would you agree? Okay, so I've rearranged that one, I divided it by 2. I've rearranged that one, I split it up as a product. Okay, I'm coming back over here, see this? Instead of log of x, I can write y over 2, can't I? So 1 plus y over 2 equals y plus 4. Okay, I'm putting everything over 1, I'm getting a common denominator is 2. 1 into that goes twice, 2 multiplied by whatever is above the line. 2 into 2 goes once, 1 multiplied by whatever is above the line. 1 into 2 goes twice, 2 multiplied by whatever is above the line. 1 into 2 goes twice, 2 multiplied by whatever is above the line. I can drop my common denominator because I've evened up both sides. So I'll get 2 plus y equals 2y plus 8. And rearranging that, I'll end up with y on this side equals minus 6. Yeah? Are we okay? Good? Questions? Does everyone see where I manipulated everything? Moved it? Any questions? How did I go from there to there? Anyone stuck? So I use this and substitute it in here. Okay, and to be honest, I hadn't a clue how to go about that to start with. Okay, so you just have to play around with these. You're going to get stuff, you're not going to have a clue where to go with it. Okay, right, so I'm going to talk about graphs of logs. Okay, now this for your notes, there's not a lot on graphs of logs. Graphs of, actually I might do it over on this side. Okay, so what I'm going to do is I'm going to graph y equals log of x to the base 2. Okay, so I'm going to graph y equals log of x to the base 2, right? Okay, and I'm going to graph it between 0 and 4. Okay. 2, sorry, 2. Okay, so let's get a few points. You can use a calculator, right? Okay, if you want, f of x table, whatever. Okay, I'll just substitute, so y is equal to log to the base 2 of 0, right? Okay, right, log of 0 is always, doesn't exist. You can't get the log of 0, you can't. Doesn't exist. Okay, right, so I have the point not infinity. Yeah, infinity means it doesn't exist, right? Then I'm going to go, x is 1, so that means, so I'm going to put in a 0, put in a 1, so y equals log of 2 to the base 1, right? So 2 to the power of what gives me 1, 2 to the power of 0 gives me 1, doesn't it? So that's the point. I put in a 1, got out a 0. We okay? Then when y is 2, y equals log to the base 2 of 2. So that's 1. So I put in a 2 and got out a 1. And I'm putting in a 3. So y equals log of 2 of 3. And I'll need a calculator for that. 2 to the power of what will give me 3, 2 to the power of. Someone do that in the calculator for me.
1.58.
What's it?
1.58.
1.58, that'll do me. Okay, so I put in a 3 and got out of 1.58. And then 4, y equals log of 4 to the base 2. So 2 to the power of what? Give me 4, 2. Okay, you can use your calculator for these. So that's 4, 2. Is that okay? Right, so I'm going to log. You can't, I didn't do any negative numbers. You can't get the log of a negative number. So that's why the x's are always positive. X's are always positive. You can't get the log of a negative number, so there's no ones where x is negative. Okay, so graphing that, okay. Okay, so 1, 2, 3, 4, right, okay, and it's 1, 2, 3, 4, okay, so not minus, it's not infinity, it's actually minus infinity, okay, 0, 1, or 1, 0 even, right, 2, 1, cross 2 up to 1, 3, 1.58, so it's a bit past there, 4, 2, okay, this is what a log graph looks like, okay. So that is y equals log of x to the base 2. Is that alright? Okay, log of x to the base 2. Are we all good with that? Okay, observations. What you think is happening here? It's heading for the y-axis. Do you think it ever gets there? No, it never gets there. So it gets, you know the way 2 to the power of x? You know, if I did 2 to the power of x, it would be that 1, 2 to the power of 1, 2 to the power of, that's 4, and that would be, and so on. So remember this was, sorry, that's really bad. Okay, remember this, y equals 2 to the power of x. You know when we did y equals 2 to the power of x, it headed towards the y-axis, but it never got there. It got smaller and smaller, the fraction got smaller and smaller and got closer and closer, but it'll never get there. Well, the log is the same, right? Okay, this time the x-axis was an asymptote to that graph, whereas the y-axis is an asymptote. So remember, an asymptote was a line where it gets closer and closer to, but it never actually gets there. Is that alright? Okay, so y equals log of 2 to the log of x to the base 2 is that line there. Okay, right. It's any other observations? Tell me about the shape of the graph. Is it pretty similar? Would you think? Pretty similar. Mine might look pretty similar, but is it pretty similar? It's actually a reflection of y equals 2 to the power of x in the line y equals x. So it's actually what you call that, axial symmetry in the line y equals x. Right, it's a mirror image. Right, is that okay? So remember y equals 3 to the power of x. Right, I might choose a different colour pen. Right. So y equals 3 to the power of x. Remember y equals 3 to the power of x. It would have got nearer, it would still cross at 1. Oh, for God's sake. But it would get nearer to the y-axis. Remember that? Y equals 3 to the power of x. Right, so a mirror image of that, it actually gets nearer to the x-axis this time. So look, again, the y-axis is an asymptote. Right, so this is y equals log to the base 3 of x. Does that make sense? Right, okay, so, you know, here they got nearer. The bigger the number, the nearer they got to the y-axis. Here, the bigger the base, the closer they get to the x-axis. Here it was heading for the x-axis but never got there. Here it's heading for the y-axis but never get there. Here it crossed the y-axis always at 1. Here they all cross the x-axis at 1, okay? So it's a mirror image, it's the opposite to what y equals 2 to the power of x. So if I had y equals 10 to the power of x, right, okay, so y equals 10 to the power of x, again it would get nearer and nearer. It would still cross at 1. Again, it's nearer to the x-axis. So log to the base 10 of x, right, okay, was, this time it would be nearer to the x-axis, okay? So it's the mirror image. They're the mirror image of each other. Because remember, logs and indexes are the opposite of each other. So that would be log to the base 10 of x. Does that make sense to you? Right? There's no log graph over here because you can't get the log of a negative number. Right? So you can't get the log of a negative number. So the graph never comes over here. Right? It never comes to the left of the x-axis. Right? The same way you, an index, if you do 2 to the power of something, you'll never get a negative number. So it's never below the x-axis. For the indexes, it's never to the left of the y-axis, I meant to say, for the logs. Yes?
Is the mirror image the two black lines?
Yeah, so that one and that one are mirror images. The two red lines are mirror images. The two green lines are mirror images. Okay? Mirror images in the line y equals x. So y equals x is the line that goes through 1, 1, 2, 2, 3, 3. Do you know that? 0, 0, 1, 1, 2, 2, 3, 3, and minus 1, etc. Do you know that line? Okay, so it's axial symmetry or the mirror image in that line. Okay, right? So you don't, same way for the indexes, you don't need to know a whole lot about the graph. All you need to know is the y-axis is a asymptote. They always cross the x-axis at 1, and the bigger the base, the closer they are to the x-axis in this case. Right? Okay, and it's the mirror image in, or axial symmetry in the line y equals x of the corresponding index. So y equals 2 to the power of x, y equals log of x to the base 2 is the mirror image of it. Y equals 3 to the power of x, y equals log of x to the base 3 is the mirror image. Right? Is that okay? That's all you need to know about log graphs. Are we okay with them? Okay, well, I just give you a couple of questions to do before I move on, because I'm not staying too long at this section because there isn't a whole lot to know about it. Okay, so will I just ask you to do page 492, right? Okay, if you do, let's do 1, 2 and 3 and move on. Right, okay. Let's do 1 and 3, do mind number 2. Let's do 1 and 3 and move on. Right, okay, so 1 and 3, I'll put it up now, and you're doing them now, and then we're moving on. Yeah, bathroom, yeah. Yeah, you might as well all go, the whole class into the bathroom. Right, 1 and 3.